Hi, I'm Joel.
Hi, I'm Yang Kai.
Hi, I'm Marcus.
Hi, I'm Hindun.
Hi, I'm Angela.
A very good afternoon to Prof, Instructor Fiona, and TAGG. We are Team 1, and our group comprises of myself, Joel, Angela, Hindun, Marcus, and Yang Kai. Today, our group will be presenting on our BPAS project report tool. This will be the flow of content that we'll be covering for today's presentation. I will be giving a brief summary of the key changes that we have made to our as-is process, as well as our justifications. Even though we have made numerous improvements to the as-is process workflow, I will only be going through two main changes. Firstly, the current as-is process has several occasions where business participants are required to walk around the supermarket to locate the next person in the process. With 8 deliveries being done in a day, this results in a lot of time being wasted. With the implementation of the headset communication device, we are able to shorten this activity duration from 5 minutes to 30 seconds, as business participants no longer have to walk around searching for people. Next will be the digitalization of documents. The current as-is process uses a paper-based invoice where a storeman has to manually update the inventory systems. This activity takes up a lot of time and is also prone to mistakes. Hence, we've decided to have a new system called the G1T6 system that is able to generate and receive e-invoices. This system is also capable of updating the perishable inventory system and non-perishable inventory system once the source supervisor confirms that the goods arrive tallies with the invoice. This automatic process is more efficient and effective compared to the manual keying in of data. I will now pass on the time to Yang Kai, who will be taking us through our goals and analysis.
Thank you, Joel. I will now be going through the goals and analysis of our to-be process. We have set 3 different process performance goals. Firstly, to reduce the average time taken for delivered goods to be shelved or stocked by 15%. Secondly, to reduce the number of manual activities by 20%. Lastly, to reduce the overall cost of one instance of delivery by at least 25%. So what kind of improvements did we actually see in our to-be process? First, the number of possible paths decreased from 5 to 3. The 2 paths that were removed were previously considered leakages in our as-is process that not only added on to the overall cost, but also did not actually provide any revenue. There was also a significant reduction in average cost and execution time of at least 27% and 22% respectively among the remaining 3 paths. Lastly, the most commonly occurring path had the highest reduction in average cost and execution time. This is crucial as it ensures that costs are kept low given the high frequency of the path. Did the improvements actually allow us to achieve our goals? Let's take a look. As mentioned previously, average time and cost have been reduced greatly such that they fall within the performance goal. Manual activities have also been reduced by 29%, meeting the goal of 20%. Hence, all 3 of our performance goals have been achieved. Now, Hindun will talk about how IoT can be used to improve our to-be process.
Thank you, Yang Kai. I'll be sharing the IoT for my group's to-be process. Firstly, we will implement the inventory management robot. In short, we'll call it IMR. IMR is a cloud-assisted robot to reduce the time taken for a specific task. It has a scanning and weighing function to deduce the quantity of goods. Once the tally of goods is done, the count of goods will be automatically updated in the store's G1T6 system. This will minimize the activities like retrieving and counting of the quantity of goods done by the storeman. The second IoT is the high-definition fish eye camera. It is an IoT device that processes the images in real time. This camera will be located and positioned at every store shelf so that it can identify the number of goods located that needs to be stocked up. The data collected will be sent to the G1T6 system so that the other systems are informed about the quantity of goods needed for shelving. The last IoT is the shelf inventory robot. It reduces the manual labor needed for the task. For example, the food processor and store clerk checks their respective inventory system to access the quantity of required goods for shelving before heading down to the unloading bay. With the shelf inventory robots, this will omit their manual process, and the G1T6 system will communicate directly with the shelf inventory robot based on the fish eye camera's data on the goods required to shelf. Ultimately, this IoT will reduce the time taken as the manual task of the store clerk who shelves the required goods. This will eliminate time by 10 to 15 minutes. Now, I'll be passing my time on to Marcus.
Thank you, Hayden. For improved workflow with IoT, I'll be going through the main differences in comparison to our to-be workflow process. To recap, we'll be including the IMR, High Definition Fisheye, and Shelf Inventory robots. When the delivery man arrives, G1T6 immediately provides IMR with the relevant information on the arrived goods from the e-invoice and directs the IMR to tally the goods with the information provided. Subsequently, IMR informs G1T6 on the result of the tally. In this portion, IMR replaces SM activity to tally the arrival of goods by scanning and weighing the goods. After the tally of goods, G1T6 will retrieve real-time data from the fisheye camera on both the perishable and non-perishable goods required for shelving. Food processors and store clerks no longer have the access into the relevant inventory system to find out the amount of required goods for shelving. In addition, once G1T6 determines how much of the arrived goods is required for shelving, it will direct the IMR to store the required goods for storage and the SR to transfer the required goods for shelving. The storeman no longer has to key in the amount of goods taken for shelving, as the quantity will be automatically updated in both the inventory systems. While the IMR transfers the goods for storage, G1T6 will check for expired goods to return simultaneously, after which G1T6 will inform IMR if there are any expired goods retrieved. In a scenario where there are expired goods retrieved, IMR will retrieve and transfer the goods from the storeman to the unloading bay. At the unloading bay, the delivery man will verify the amount of expired goods. Subsequently, the expired goods will be handed over to the delivery man by the IMR. Now I'll be handing over my time to Angela, who will talk about the possible challenges when using IoT.
Thank you, Marcus. Next, I will share with you more about the challenges with using IoT. So the first challenge is that the various IoT technologies is heavily dependent on internet connectivity. As the store's G1T6 system already has existing interactions with the store's inventory system, introducing robots that relies heavily on the data and command from G1T6 may potentially cause bottlenecks in the process. Furthermore, if internet accessibility by these devices are affected, it could lead to an overall halt to the process, which will have a major impact to the company. The second challenge is the compatibility issues between the systems. As there's a possibility that the implemented IoT technologies are not compatible with the existing IT systems, the company may have to deploy additional hardware or software for integration between the systems. Furthermore, it is also very important to ensure that the IoT devices used are constantly updated as different software versions might face performance and security issues. Thus, with the deployment of technologies being highly dependent on the suppliers, this may pose a risk to the usage of such IoT technologies. Next, I'll be going through the improvement using the non-IoT technology. So initially, the food processor, FP, has a task which is to manually cut and weigh perishable food, and this takes about 30 minutes. Thus, a non-IoT technology that we can utilize for this task is to replace it with a machine that helps to portion the food accurately. This will reduce the time taken to package and portion the food significantly from 30 minutes to about 10 minutes or so, and hence reduce the overall process time for the goods to be shelved. With that, we have come to the end of our presentation. Thank you.